Hi, this is the chemical analysis knowledge test video. Okay, it's a relatively short one. Right, so first thing is, what is a pure substance? A pure substance is a single element or compound not mixed with anything else. Okay. Right, so that is a pure substance. It's just when there's one individual thing that's then in the actual substance itself. Draw the melting point graphs of a pure substance and an impure substance. Now these are significantly different, right? So the axes are then the same. A pure substance, right, what it does, it goes up, and this is then temperature on this side, okay? Then what it does, it goes flat, it then goes up, okay? That is then the melting point of a pure substance. So what happens is as it heats up, it's a straight line, then it goes straight across, and then it goes up. An impure substance, it goes like that. Okay, well, it's a curve, and it's much more gradual because there's other things in it that are then making the melting point not exactly and precise. What is a formulation? It is a mixture designed as a useful product. Okay, so formulation is a mixture designed as a useful product. Give 3 examples of formulations. So things like tablets. Okay, so what you got is you've got your paracetamol, and it's got exactly the same amount of paracetamol and exactly the same as other substances in there. Baby powder, all right, or baby milk rather. Right, so baby milk, what you do is you might get 0 to 3 months, 3 to 6 months, 6 to 12 months, I'm not quite sure exactly how it goes, but the formulation of each one is specific as a useful product. And the third one is then paint. So paint is very, very specifically designed as a mixture to give any one of the many, many hundreds of different colours you can get. Okay, so question number 4, what is the separation technique shown below? Right, and then I'll go through each individual section. So the separation technique is chromatography. Okay, chromatography. What does it separate? Right, so what you're talking about then is the main 2 things that are ever separated, okay, are ink or usually food colouring. And it's based on its solubility. All right, the more soluble it is, the further it goes up the piece of paper. RF value. How do we calculate the RF value? Right, so what you do is RF equals distance travelled by the compound, the spot, the colour, divided by the distance travelled by the solvent. Okay, so what I've got is that is the solvent, and what you do is you can calculate that distance there. So let's say that distance there is 6 centimetres. Then what I'm going to do is the distance travelled by the compound, I'll do it in red, it's from there, that is then the distance travelled, and we'll call that 4 centimetres. To calculate the RF value, what you do is you do the 4, which is the distance travelled by the compound, divided by 6, which is the distance then travelled by the solvent. 4 divided by 6 is then your answer. Is it pure or a mixture? Right, it is a mixture, oops, because there is 2 dots. Is